Now the choice of the constrained loop isn't unique. Let me put my constrained loop for this example in a different spot and see what happens. I'll still choose the same mesh currents, so I'll have I1 going around here and I2 going around here. And the way I chose those is the same way I did before. However, now for our constrained loop, let's go around here through the 2 amp source, because it has to account for that current, down here and around through here. That'll still be 2 amps. It's still going in this direction, and it still accounts for the current in that source. Now let's write KVL around the 2 mesh loops. So for loop 1, I'm going to still start down here. I'll see negative 12 volts plus 3 ohms, and I'm setting this voltage polarity based on the direction of mesh current I1. So I1 plus 2 amps, since that's also going in the same direction, plus 1 ohm now. Now the only mesh current going through this 1 ohm resistor is just I1, plus 3 ohms times I1. I2 is going in the opposite direction, and the 2 amp constrained loop is going in the same direction as I1. That brings me back to my starting point, so that equals 0. Notice that I'm not setting my sign convention for this term associated with what I want to find. By coincidence, that's the way it works out, but I'm not doing that on purpose. I'm ignoring the voltage V for the moment. For loop 2, going here, now I'm going to set my polarity according to the current I2, so this is my positive terminal. So I have 3 ohms times I2 minus I1 minus my 2 amp constraint, because that's now entering this negative terminal, plus 6 ohms times I2 is the only mesh current going through that 6 ohm resistor, plus 6 volts is equal to 0. Finally, to find the voltage V, and now I do have to stick with the given polarity, so currents entering the positive terminal are treated as positive, currents entering the negative terminal are treated as negative. So I have 3 ohms, I1 enters the positive terminal, 2 amps enters the positive terminal, and I2 enters the negative terminal, and that's also a perfectly legitimate solution for this problem.